Here we're finding the domain of a function to start. When you see a complicated function like this, you want to break it into its pieces. So you're going to find the domain of each piece, which is going to make the domain of the whole thing. First thing I'm going to look at is this square root of 4 plus x. So let's think about what do we know about just normal square roots. So a square root function, if we think about what x's we can plug into this function, can we plug in negatives? No. Can we plug in 0? Yes, we can get 0 if we plug in 0. Can we plug in positive numbers, say like 16? Yes, we can do the square root of 16. So that means that the domain of a square root function, we can plug in 0, and we can plug in anything bigger than 0. So it's anything bigger than 0, that would be its number line. But this function has a plus 4. So we got to think, well, how is that going to affect it? So what we see is that square root functions have to be greater than or equal to 0. The x's have to be greater than or equal to 0 if it's going to be in its domain. So what we would do is we would just set this radical or square root greater than or equal to 0. So let's do that. Off to the side, I'm going to subtract 4. So that means that this function, because of the 4, my numbers aren't going to turn negative unless they go smaller than negative 4. So you can test that if you don't trust the graph. So like if you test negative 5, that gives me a negative in the square root, which is imaginary. It doesn't work. If I test negative 4, it gives me 0. Square root of 0 is 0. That works. If I test negative 3, plug that into the function. I get 4 minus 3 is 1. Square root of 1 is 1. It works. So right now, the domain for the top function is negative 4 to infinity. Then I noticed that there's a function in the bottom. What can we never have in the bottom of a function? We can never have 0. The bottom can never equal 0. So what we're going to say is that the bottom can never equal 0. Then if you want to solve that, you could subtract 1 to the other side, you can divide by your negative 1, or you can just think about it. So x cannot be 1. So the domain for this part of the function would be everything except for 1. So all the numbers smaller than 1 would work. All the numbers greater than 1 would work, but 1 would make 0 in the bottom and doesn't work. Now we are going to combine these domains together. So we're going to look at the domain of the top, the domain of the bottom, and combine them. Whenever you're looking at a domain of a function, it always starts as negative infinity to infinity. At first, we assume that all x's are going to work in a function, but then certain things might happen. For example, the top restricted this domain from from negative 4 to infinity. From negative 4 to infinity. So we're actually going to start at negative 4, which means we cannot go to negative infinity. We can't go beyond the negative 4. Then we look at the bottom of the function. Whenever we're dividing by an x, that's going to create a restriction. So then we saw that 1 does not work. So we had an open point at 1. So then that changes my shading, because we're combining the two ideas together. So we can shade from negative 4 to 1, and then we can shade from 1 to infinity. So now that is the domain of the whole function. So I would say the x's are a subset of negative 4 in brackets to 1, meaning we include negative 4 but exclude 1, union 1 to infinity. So this is my domain. Remember, domain are referring to the x values that work in a function, and range are the y values that work for a function. Here, they give me different elements of the domain. They want us to plug them into the function. So we're going to plug in 5. So we would get 4 plus 5 over 1 minus 5. Here I'm getting square root of 9 over negative 4, which would be negative 3/4. So that is what you would get. If you plug in negative 2, and then I think the idea here is to look, when you see what you're plugging in, you notice, oh, negative 2 is in that shaded section, so it's going to work. If I plug in negative 2, I would get square root of 4 minus 2 over 1 minus negative 2. And here I'm getting square root of 2 over 3, so radical 2/3. Now we're plugging in negative a, so we're going to get 4 minus a over 1 minus negative a. So we get square root of 4 minus a over 1 plus a. So this is the answer, but we would need to just make sure that a has to be in the domain. So a has to be in that domain. But right now we can just leave it like this. Then if I'm plugging in negative, or here I'm just plugging in a, but I'm putting a negative on the outside. So this is a little bit different. Up here, notice we plugged in negative a on the inside of the function. Here, we're only going to plug in a, but the negative is going to be outside of the function. So how would I write that? I would write negative, then I'm putting my g of x, then I'm going to put my g of a. So I plug in the a, positive a, over 1 minus positive a. So here the negative is on the outside, and I see positive a is on the inside. So that would give me just negative radical 4 plus a over 1 minus a. And again, this would only work if a is in the domain.